Determine if the sequence converges or diverges. If it converges, determine its limit. So here we got several terms. The general term an is not given, and we don't have to find that. Let's try to figure out if this is a geometric sequence. That means if there is a common ratio. How do we find common ratio? Let's divide first by second and third by second. Okay, second by first. What did I say? Second by first, third by second, fourth by third. If they are same, that's the common ratio. Okay. Second negative 4/3 divided by 2, which is negative 4/3. Keep change. Now we flip. 2 means 2 over 1. So 1/2. 2 goes for 2 times. So that's negative 2/3. If third divided by second is also negative 2/3, then this must be a geometric sequence. Third 8 over 9 divided by second, negative 4/3. 8 over 9 times flip negative 3/4. 4 goes twice. 3 goes 3 times, negative 1. So negative 2/3. Okay, so this is a geometric sequence with common ratio negative 2/3. And we know that when we have a geometric sequence and the common ratio is 1 all the way to negative 1. Negative 1 is excluded though. If the common ratio is inside here, including 1, excluding negative 1, then the sequence converges. If the common ratio is not 1, any other things, then they are eventually going to 0. So in this case, negative 2/3 is somewhere here, and here is 0, negative 2/3 somewhere. So, which is strictly less than 1. The absolute value is strictly less than 1. So this is going to go to 0. So the sequence converges to 0. So let me move this away from here. Okay, because it's the geometric sequence with common ratio negative 2/3 or absolute value of common ratio, which will be without negative now, that is strictly less than 1. If the absolute value of common ratio is strictly less than 1, then the sequence eventually go to, the terms of the sequence go to 0. Here, same idea, let's find the common ratio. Second divided by first, negative 3. Or, okay, I can't say common ratio until I find the same pattern. Third divided by second is also negative 3, which is, if we look at the previous one, we have to have in between negative 1 to 1 so that the limit will be 0. Even for 1, that's fine. When there is 1, still the sequence converges, but not at 0. So it's less than 1, converges, outside diverges. So the sequence, as you can see, the numbers are getting bigger and bigger with plus minus. So they are not going to stop to a finite number. Okay, the sequence diverges. Now the third one, negative 1 to the n. So negative 1, so this is a geometric sequence with common ratio negative 1, diverges. It has to be in between negative 1 and 1. 1 is included though. Okay. Geometric sequence with common ratio negative 1. That means this sequence diverges. If you expand, if you try to find the points, the terms here, n equals 1, we get -1, +1, -1, +1. So these numbers are not going to a finite, a single number. And these terms oscillate between -1 and 1. That means there is no limit. Limit means one unique value, but that's not the case here, so diverges. Okay, here -1 to the n plus 1. The top alone would be like previous, but here is n. So if we look at a couple of terms, we take n equals 1, so it will be 1 over 1. N equals 2, -1/2. N equals 3, 3 plus 1, 4, -1 to the 4th is positive 1/3, -1/4. Okay, almost like previous, but now these numbers are getting smaller and smaller. And when n is really big, they are going to go to either -0 or +0. So here these numbers are either go to -1 or 1. There is not a finite number. That's why the limit, this sequence diverges. Here these numbers are getting 1/5, -1/6. These are smaller and smaller in quantity, but plus minus, so they are gonna go to either -0 or 0. But -0 or 0, same thing. That means this sequence converges to 0. Okay, that one way to check. But if you want to write down the reasoning here, we can take the limit of its absolute value. When limit of absolute value goes to 0, if this limit goes to 0, the limit of without absolute value also goes to 0. We were supposed to find the limit of this thing without absolute value, but that's difficult. So I want to take with absolute value. Let's see that. This absolute value will make everything, every term positive. So when we take absolute value, -1 raised to n plus 1, this is going to be always +1. I mean, this one is now +1, -1, +1, -1, but with absolute value it's going to be always 1. So this is same as limit in approaching infinity of 1 over n. I don't need absolute value anymore because these are both positive terms. And 1 over n, when n goes to infinity, is 0. So the limit with absolute value goes to 0 means the limit of this without absolute value also goes to 0. So since then limit of this n without absolute value is also 0. That essentially we found that this sequence converges to 0. That is, the sequence converges to 0. And we observe that here, because these terms were marching towards -0 or 0, and in fact they are same. So final